हेलो स्टूडेंट्स, वेलकम टू फिजिक्स पाठशाला। आज हम लोग पढ़ेंगे अबाउट थर्मल प्रॉपर्टी ऑफ मेटल। आज द नेम इंडिकेट्स थर्मल लिंक टू हीट। In this, we will study how matter will behave when it will come in contact with heat and how heat is useful in industry, how we use it, what are the formulas we will get related to heat. In that, we will make two categories. One is temperature measurement, another is heat measurement. The branch of physics in which we will study temperature measurement, we say it is thermometry, or branch of physics in which we will study heat measurement, we say it is calorimetry. That means this chapter will be studied in two categories. One will be under thermometry and another is under calorimetry. Thermometry will deal with temperature measurement and calorimetry will deal with heat measurement. Okay, as you know, temperature indicates the hotness. Temperature indicates hotness or coldness of an object. When you compare between two objects having different temperature, having different hotness, we say if this object is more hot and suppose there is object A, there is object B, if we feel A is more hotter than B, then we say B is cold and A is hot. In that case, in that case, we when you try to measure how hot it is, we take the help of temperature. That means temperature indicates the hotness or coldness of an object. Here, this temperature or hotness came due to the energy inside the object. That is, some form of energy that is available inside the object that indicates in the form of temperature. As you have practiced, in practical life we have seen, if two objects A and B having one is more hot, another is cold one, when they come in contact, they will come in contact, then some energy will be transferred, some energy will be transferred to cold object from hot object. In that cold ऑब्जेक्ट का हॉटनेस बढ़ जाएगा और हॉटर ऑब्जेक्ट जो है इसका हॉटनेस डिक्रीज हो जाएगा, इसका हॉटनेस विल इंक्रीज. इसका मतलब some energy, something will be passed from hotter object to cold object so that hotter object will become less hot or it will become cold, whereas colder object will become little hot. इसका हॉटनेस बढ़ जाएगा और हॉट ऑब्जेक्ट का हॉटनेस घट जाएगा. तो क्या हो रहा है इन दैट, व्हाट इज हैपनिंग इन दैट, some energy is transferred when two objects are kept in contact. तो वही एनर्जी को हम बोल रहे हैं दैट इज we say that is heat. That means heat is some form of energy that transfers from a hot body to a cold body when both are kept in contact without involvement of any mechanical work. In this transfer of energy, no mechanical work is done as there is no involvement of any external force or there is no displacement of the object as a whole. तो इसमें ना कोई फोर्स लगाया ड्यूरिंग ट्रांसफर ऑफ दिस एनर्जी, ना कोई ऑब्जेक्ट दोनों में से कोई डिस्प्लेस हुआ ड्यूरिंग द प्रोसेस ऑफ ट्रांसफर ऑफ एनर्जी। तो उस केस में, उस सिचुएशन में जो एनर्जी ट्रांसफर हुआ हॉटर ऑब्जेक्ट से कोल्ड ऑब्जेक्ट को, हॉटर ऑब्जेक्ट का हॉटनेस घट गया, कोल्ड ऑब्जेक्ट का हॉटनेस बढ़ गया, उस फॉर्म ऑफ एनर्जी को बोलेंगे दैट इज हीट। कैन नोट डाउन, heat is a form of energy that transfers from a hot body to a cold body kept in contact with it without involvement of any mechanical work. In that हमने क्या देखा, हॉटनेस इसका बढ़ गया तो उसको हाउ टू फील इट, तो वी कैन मेजर इट विद द हेल्प ऑफ टेम्परेचर, कितना हॉट है कितना कोल्ड है, तो दैट विल बी मेजर्ड और इंडिकेटेड थ्रू टेम्परेचर। तो दैट मीन्स टेम्परेचर इंडिकेट्स हॉटनेस और coldness of an object. Now we have different scales to measure temperature. We have degree Celsius, we have degree Fahrenheit, we have Kelvin, we have the Reaumur scale. In that we take two reference points. In that we take two reference points while using this different temperature scales. Reference points are, one is ice point and another one is steam point. Ice point is the temperature at which ice and liquid water coexist in its thermal equilibrium. In its thermal equilibrium. This is in degree Celsius, it is 0 degree Celsius. Whereas at steam point, water, vapor and liquid water coexist at its thermal equilibrium. This is observed and this we have taken as 100 degrees Celsius. Correct? Now we have 100 divisions between these 2 points. Another scale is degree Fahrenheit, in which ice point is 32 degree Fahrenheit and steam point is 212 degree Fahrenheit, and there are 180 divisions. Another is Kelvin scale, where the ice point is 273.15 Kelvin and steam point is 373.15 Kelvin, and there are 100 divisions between these 2 points. Another one is Reaumur scale, that it is 0 degree Reaumur and boiling, the steam point is 80 degree Reaumur. And there are 80 divisions. This ice point is the melting point of ice. This is the melting point of ice. The steam point is boiling point of water. The boiling point of water. Now we found there is some relationship between different scales. Suppose you reading, want to convert reading in one scale to another scale, suppose from Fahrenheit to degree Celsius. Now you observe at 0 degree Celsius, suppose it is 50 degrees Celsius, this is 100 degrees Celsius. Here we observe at 0 degree Celsius, ice exists, and this corresponds to 32 degree Fahrenheit, and 100 degree corresponds to, suppose it is to 1 degree Fahrenheit. We have different points. Suppose now this point it is 0, 32, whereas this is 100, 2, 1, 2. Suppose one point we want to find out here, that is our C and F. Now we have two triangles. Suppose it is A, B, C, D, E. Between these two triangles A, B, E, A, B, E, and triangle ACD, we observe both triangles are similar, hence we can write BE by CD is equal to AE by AD. This implies B, this BE is F minus 32. F minus 32 divided by CD. This is 100 minus, this CD is 212. 212 minus 32. Now this is equal to AE. AE, suppose this is some arbitrary temperature E. Arbitrary temperature is C. Then AE is how much? C. Now this BE by this one is equal to AE by AD. AE is C. This is C minus 0 divided by this 100 minus 0. We see this is F minus this 32 is ice point divided by steam point minus ice point is equal to C minus ice point by steam point minus ice point. Similarly, we can compare with other scale, Kelvin or Kelvin scale, K minus ice point by steam point minus ice point. For inverse scale again, you can write R ice point by steam point minus ice point. Correct. Now we got this relation or an equation. इसी के help लेके, with taking help of this equation, we can convert any convert temperature of any object in any scale to another scale. Suppose we have a uh, temperature in degree Celsius, it is 60 degree. Then we have to find out, suppose it is 0 degree Celsius, it is 60 degree Celsius. It will be how much Kelvin, it will be how much degree Fahrenheit. In that case, we can use this formula, is Fahrenheit minus 32 by 212 minus 32 is equal to C minus 0 by 100 minus 0, or F minus 32 by 180 is equal to C by 100, C by 100. Now, it became C is equal to, F is equal to, we have to find out F. Apply that F minus 32 is equal to 18 by 10 into C is 16, or F is equal to 10 into 6 is, it became this value is now 108 plus 32 plus 32, which became 140. That means it is 140 degree Fahrenheit. Similarly, when you convert it to Kelvin, it will be C minus 0 by 100 is equal to Kelvin minus 273 by 100. So now cancel K is equal to C plus 273. It is 60 plus 273. Now it became 333. It became 333 Kelvin. So with this relation equation, we can convert any temperature in any scale to another scale. This is how we will convert temperature from one scale to another scale. So now this temperature indicates hot smell, but what it is exactly? We know every material is made up of molecules, and each molecule inside a material, due to its kinetic energy, it's in motion. It is in, molecules are in motion. This motion may be translatory motion or straight line motion. Another is vibratory motion, means they may be vibrating, they are vibrating about a mean position. To and fro motion. This is to and fro motion. Suppose it is making horizontal vibrating motion, they will move about its mean position. this side, it will go this side, it will come to mean position, it will come to again left side, it will come back to its mean position. This position, mean position. This type of motion is vibratory motion. Another motion is molecule may rotate about its axis. It is rotational motion. This translational motion normally happens in the molecules of gas, whereas this vibratory motion happens in liquid, solid, liquid, and rotational motion happens if more energy is given in gas. That means molecules of gas will start rotating about its axis. Here, what happens? Once heat is given, once heat is given, the molecule inside an object adjusts this heat and its is kinetic energy of molecule is increased. So what is happening that once heat is given, molecules absorb this heat energy and their velocity, their motion or velocity is increased. That means they start vibrating. They start vibrating at a higher velocity. In that their kinetic energy is increased. In that their kinetic energy is increased. Hence, temperature we can say it is the average energy of of molecules of an object. This is the molecular phenomena linked to temperature. Okay. In our next class, we will study about effect of this heat, how objects expand. Objects expand. That means in length, if it expands, we will say it is linear expansion. If it expands, its area is expanded, then we say it is superficial or areal expansion. If volume is expanded, volume of an object is increased, we say volumetric or cubic expansion. Expansion. We will study this expansion of objects once heat is given in detail in next class.